Hi, my name is Rodrigo Picos, and I'm going to present you our poster entitled Empirical Modeling of ReRAM Measured Characteristics Using Charge and Flux. The main idea of this poster is to show how we can implement a very simple empirical model describing an apparently complex behavior of a ReRAM device. Okay. To do so, we have used these devices that were fabricated in using a hafnium dioxide of the switching material, of the switching layer, with ranges between 2 by 2 squared micrometers and 120 by 120 micrometers. Okay, we used this forcing current to measure the devices. Okay, this measuring current. So it's a very strange shape. Yeah, I know. It's a triangular current waveform with increasing amplitudes that provides us with the other IV curves that they are complex. Yeah, they look complex at least. Okay, so in order to model that, we used the typical way to model using charge and flux. So we first define the charge as the integral of the current, the flux as the integral of the voltage, and we define our model as just a simple power relation between the flux and the charge. Okay, using this simple relation, we can develop a relation for the current and also a relation for the conductance. Okay, but the model is just this power relation. To fit the model to the experimental measurements, we just got these IV measurements, these IV curves, and we integrate them. Yeah, I know, it's beautiful. I mean, we just get this power relation, this very nice curve, and fitting this model provides us with those parameters. Okay, with a very simple relation. And then using this relation, we just get these results. We are able to reproduce the IV curves. Sorry, the IV curves. We are able to reproduce the IV curves. We are able also to reproduce the current by using the measured voltage. So we measure it using current, but then we can reproduce this measured current by using the measured voltage, getting the model. So measuring just in the opposite way. And we are also able to reproduce the conductance. Notice that the conductance has some small variations there that are caused by the effect of the capacitor. Since we are measuring current, we are forcing with current, this current goes through the capacitor and makes these second order effects. But in any case, the first order model reproduces the IV with nice accuracy. Okay, so that's all. Thank you for your attention.